Hello dear do-it-yourself friends. In this video I will cover every step from printing to testing of my completely printed CNC. Have fun! When it comes to printing, I think I printed between 80 to 100 hours and I actually don't know how much filament I used because I said to myself it's going to use as much filament as it's going to use. Most parts that needed a certain stiffness, like the sidewalls or the gliding rails, I printed with 3 walls, 35% infill at the speed of, I believe, 80 millimeters per second. In terms of failed prints, I had one corrupt G-code, which stopped the whole print after, I think, 95%, so I had to reslice and start again. And all the other parts that didn't work out very well didn't stick to the print bed. And I couldn't use, for example, wheels that weren't straight because of the precision. As most of you probably know, I used the technique of applying a very thin layer of white glue before printing and then pausing the whole print after the outline of the first layer was made. And I followed it with super glue. And this combination actually never failed me, and I could have it print for 8-10 hours without a problem. The heat bed was heated to, I think, 35 degrees, which didn't dry the white glue too quickly, so that the first layer could adhere to it very well. But see for yourselves. Yay! That was fun! Whatever. But now to a very personal topic I would like to talk about. Personal hygiene. You know, most people don't know, but hygiene is very important for the future well-being of your completely printed CNC. That's why I personally will take care of all the newly printed parts and clean them thoroughly so that we don't have any problems later on when assembling the machine and using it after having assembled the machine. Okay, good. Let's start. Yeah, let's go to the toilet first. It's gonna take a while, okay? Yeah. I heard my cat falling. And hearing a cat falling is rather unusual, so I went looking. But all is fine, she's more or less alive. By the way, you see that's the old design I used for the X rail, and that's the puzzle design. And I changed the design because of this. As you can see, it's moving way too much. So I won't use this one. I might keep it as a replacement and put some epoxy in it, but that's the other design, which is as stiff as it should be. No worries, folks, I'm back. I cut myself and I was about to die. But I'm a very, very, very yucky lung man because I found a band-aid and now I feel much better. So I'm ready to cut myself again. My girlfriend trying to get the cat. Luckily, I'm not turning a YouTube video. But that's fine. That's fine. Still trying to get the cat. Still trying to get the cat. It's a large barn, 5 meters high. Finished! Yay! That was fun! Yeah. I don't know. I don't need to do that the second time. No, not ready. No. Meditative, yes. Fun. It's assembly time! Ha! I'm looking forward to it. See you soon. And now the moment I've been pretty much looking forward to. Assembly. So, I just printed 2 new pulleys with a slightly larger diameter, and I already tried this one on the stepper motor, and I just had to file it down a little bit. And since the tight is going to be the fit is going to be really tight, I don't think I'm going to glue it down, because if one day I have to remove them or replace them, that's going to be a nightmare, and I think that should work. What I did is just to slightly also file down the edge of the stepper. I don't know if you can see it, of the original pulley, so that it can glide easier on the pulley, and it doesn't cut the pulley with the sharp edge. So let's see how this works. That's the one I did. Yeah, I guess that should do the trick. It's really, it doesn't move it doesn't have any space, so that should be fine. Here we go. Somewhat the moment of truth, or at least the first one. Or I'll put a second wheel in between, behind here, so that it can't move. And I hope that if both stepper motors on the y-axis turn at the same time, that it will prevent the whole thing a little bit from this movement. That it will be forced to move in the same direction at the same speed, and thus avoiding this. But let's see. So this is pretty stable. I'm pretty pleased with how this is stable. As announced in the first video, one of the challenges was to carve the logo of my channel into wood. Please let me show you the result. And now the milling itself. I'm pretty sure you have never seen such milling before. But it was the most beautiful milling I ever did in my whole life. Honestly, I swear on the life of my dead goldfish. So what is my final conclusion after all of this work? Well, for a first design that was completely printed in PLA, with no screws, no glue, no ball bearings and no metal, I think it is safe to say that it is actually feasible to build a CNC in plastic. I mean, one could imagine to build them and to sell them to absolute beginners so that they can have a first hands-on experience what CNC milling actually is. I mean, I wouldn't expect them to mill metal or at most soft aluminium, but they could be used for PCB milling or for milling soft wood, or with exchangeable heads, they could be used for pen drawing or for lasering or even for vinyl cutting. If somebody wants to try this, let me give you some comments. Use other plastic than PLA. Not because PLA was completely off, but given that there are more sturdy options, use those. Use stepper motors that have a higher stepping resolution. Use a lead screw at least for the Z-axis. The problem was that to keep the spindle in a certain position, I had to permanently enable the stepper, so it got hot. And even though the ventilator did a very good job, it's not ideal. Use a more powerful spindle. I used what I had lying around that would fit in a certain weight frame. This one would have only been sufficient for milling a PCB, but not much more. Or let's say it was ready to mill soft wood, but the 1mm stepping resolution moved it too quickly for the given power and it started to block. Besides, the chuck was a little bit wobbly. And there is no replacement for ball bearings. I think that's clear. But PLA is actually sliding very well on itself, especially when using some lubricant. Some of the wheels actually never turned, but just glided, and it moved around just fine. You may have seen a bunch of cables for the end stops, but since I had troubles making them work properly, and since I didn't want to spend too much time on them right now, I disconnected them. Well, if you take advice of these comments, it may be feasible to build your own completely printed CNC. All the files are downloadable at Thingiverse, and G-codes for Ultimaker 2 plus the whole SketchUp file can be downloaded somewhere else, which you will find a link for in the description. Have fun! So what's next, you might ask? Well, I won't pursue this project any further because it would need a complete redesign for it to work properly, and I just don't want to spend that time on it. That's also the reason why there won't be a third video in this series. Instead, I have the intention to donate this machine to NASA so that they can adapt it and use it in space. I have a whole bunch of other never seen before ideas that are a little bit more down to earth. So I would be happy if you joined me in one of my next projects, which hopefully will also be using my second favorite machine, the laser. I love this machine so much. I could just... Mini Martin, stop pumping the laser. Take care, and please don't forget to stop by at Sulisha's house. Subscribe, like, share.